Good evening. Welcome to your Thursday evening stroll around your celestial neighborhood. I'm Irene Pease, your friendly neighborhood astronomer. Thanks for joining me. We're going to be strolling around some stellar moving groups this week. I really was in the mood to get out of the solar system. We've been in the solar system quite a bit lately. Um, so, time to stretch our legs, get out among the stars, all the sparkly things. I think this weekend next we're going to do starry things. So, welcome. Just to start off, the visuals that you see in the background, I'll be talking a little bit more about this one, but you can find what you see out in the background now at openspaceproject.com. So, this is a platform called OpenSpace. It's a open source software that you can use to fly around the universe, like I do. And also, we'll be flipping over to Stellarium in just a moment. You can find that and download that at stellarium.org. So we'll be using that to take a look at our night sky, see kind of a preview of some of these moving groups of stars in just a little bit. So for now, yeah, let's go ahead and pop on over to Stellarium. There she is. There's our night sky. This is Brooklyn, looking at now, like you do. Normally, I like to start off in the south. Tonight, just to mix it up, I thought I'd start in the north because there's probably nothing in the other direction. I don't know. Let's see. Well, yeah, no, it's set. All right. So if you haven't seen it yet, you missed it. So I won't even tell you how awesome it was. We'll just wait till next month. But in the east and in the northeast, there's some constellations coming up, some kind of fall and winter constellations that we'll be following and talking about extensively. And one of those is Cassiopeia. So if I turn on some kind of lines to help outline that, Cassiopeia is this kind of W or M shape high in the sky, depending on how it's oriented. So here it's a W, M. Here it's an M. But if you turn around, or if it, gets really close to the horizon, then it looks like a W. I do know my letters. I promise. I passed kindergarten, but it's just been a while. And then the M or W of Cassiopeia is basically opposite the Big Dipper. If you go through the North Star. So opposite the North Star from the Big Dipper. So if you can find the Big Dipper, kind of hard right now because it's really low on the horizon. It just kind of skims the horizon this time of year. But if you follow those pointer stars, they point to the North Star. So if you see the Big Dipper kind of partly hiding behind this tree, it's not the tree, but it's a tree. There's another tree over in the west. But if you kind of go from the Big Dipper to Polaris and then keep going, you see this kind of prominent MW shape. Since I obviously can't keep my M's and W's straight, I like to go with the ancient Egyptian kind of view of this. It was like a set of jaws. Jaws of what? I'm not sure. Guessing not a shark, maybe a crocodile, maybe just jaw bones for the sake of, jaws. I like to call them om nom nom. So that's the top jaw, om nom nom, and then nom om nom is the wider jaws. And you'll be able to see that if you go to my website. There's a little explanation of that, or there will be as soon as I get it posted. The jaws of Cassiopeia. All right, so if you can go out this week, find Cassiopeia, om nom nom, and nom om nom, the jaws. And up there, we have several open clusters. So some really nice clusters of stars that you can see in the night sky. Some you can see naked eye, some you can see with binoculars. But if you're able to get up there, check them out. We can actually see one of the clusters in here even. If we zoom in a bit, it's like a little fuzzy spot, but in just kind of zero in on that ish. We zoom in here, it looks like, well, I always thought it looked like an owl, right? So if you imagine like these are the eyes and it has like wings out, like it's coming in to land on something. Some people say it looks like E.T. I don't know, owl or E.T. You decide. But that's a nice little open cluster up there in Cassiopeia, one of many. That's NGC 457. So super fun name. Much more interesting than owl cluster or ET cluster. Another couple of clusters you have up there you can also see with the naked eye if you're in a dark spot. You can see kind of there's two clusters in here between Cassiopeia and this other constellation that we'll be looking at later this month and early next. This is Edenkai Persei, or NGC 884-869. We like to call this the double open cluster because it's like two open clusters like smack on top of each other. Really, really pretty. Lots of sparkly things to see in a telescope. Also really great in binoculars. So those are some of the really nice clusters that are over there. And then further, there's also the Pleiades, which we'll be seeing a little bit later in open space. Both the Pleiades, which a lot of folks might be familiar with, and then just below those are going to be the Hyades. So lots of open clusters. We'll talk more about these Pleiades and Hyades more into the season. But I guess for this week, the challenge would be find the jaws, find Cassiopeia, and maybe look for some of the clusters in that little part of the sky. So it should be a good week. We're just a little past full new moon, a little past new moon. So that's what was setting over there. So it's going to be getting brighter and brighter as we go through the week. So if you kind of watch the sky over the next several days, you'll see moon kind of invading. All right, so maybe check those out sooner rather than later. As the moon comes over there, it'll be a little bit harder to see some of the fainter details in there, both with your eyes and with binoculars. So go out tonight if you can, if it's clear wherever you are. So some clusters. Well, what in the world is a cluster anyway? I'm going to get there. So for that, we're going to pop back over to open space and space out a little bit. So open space, again, this is open source software you can download for free. And it comes with all kinds of data. You can load in more data if there's just not enough for you. And actually in the background just now, you can see the Pleiades and the Hyades. So those little groups of stars. Also, I usually turn off the ISS on the Earth here, but again, this is all real data. So this is how the Earth looked yesterday. And if we come in here, that's the orbit of the International Space Station that you can see going around the Earth. So I just wanted to kind of leave it on for the first part of tonight because we just got a new crew changing out. So that was kind of exciting, and a lot of people watched the next launch, sending the next 4 astronauts up to the International Space Station. It was pretty exciting. But we want to get out of town. So moving out just a little bit, we're going to go ahead and leave the solar system and turn on the orbits of the planets for reference. So those lines aren't really out there in space, but those are the actual paths that the planets take as they move around the sun. Those are actual stars, actual star positions in the background, and there's the actual sun. So we're going to definitely, start by leaving the solar system, but not quite the solar neighborhood. So I just want to get out to the point where we start to see some of the stars moving just a little bit, and so we can really get kind of a nice 3D feel for space. Because I said I wanted to talk about moving groups. So something that people ask me sometimes when I talk about star clusters and stars hanging out, in binary star systems or these little groups, you kind of have to wonder, well, what about the sun? Where's our posse? Where's our group that we're supposed to be hanging out with? So there's a couple of the names of stars that we can turn on. And just by kind of like moving around in 3D, you can tell which ones are, a little bit closer to us. We can pull out just a little, see some of the closest stars to the sun. Some of these might be familiar names. So we have Rigel Kentaurus, that's aka Alpha Centauri. A lot of people are familiar with. Sirius is the brightest star in our night sky. Vega is over there. Procyon. If I actually just turn off the turn off the labels again, you can see which stars are which stars seem to be relatively close. So this one here, I'm gonna guess, not sure which one that is, but I'm just gonna guess real quick. I'm gonna see if that's what I think it is. Nope, not what I thought it was. Okay, maybe Wolf 359. I don't know. But yeah, so there's a couple of our neighbors. One of our neighbors, if I move out just a little bit further, we should be able to see and turn on a line that shows where the sun is headed. All right, so we have all these stars around us, and this is kind of the direction that we're headed into space. This is the sun's orbit projected over the next billion years or so. So we expect it to go around the Milky Way about 4 times in that time. So are any of these stars traveling with us? I don't know. Do we have a group? Do we have some friends here? Let's see. If we turn on, ooh, there's a nearby buddy. So that blue line, that's the orbit for what we call a high proper motion star. That's the path for the next billion years of Barnard's star. It's not very bright. You can't see it in the night sky without a telescope. But you can see it with a telescope. You can tell it's relatively close by. It's not super far. Not the closest star, but one of the closest stars to us. And it kind of looks like it's going a little bit in the same direction, at least up close. As we start to see those lines in the background, I start to wonder how close they really are, the sun and Barnard's star. If this is just like, if we're just, ships crossing in the night, or are we actually moving around together? Because that's what these moving groups are, stars that are actually moving around the Milky Way together. So kind of like hanging out, moving together, or are they just, like crossing paths? So if we move way out, turn off some of these labels, but leaving those 2 orbits on, we can move out, get kind of a galactic perspective of where we're headed. And let's see. Are we traveling together? I'm going to say no. So we're kind of near each other at the moment, the sun and Barnard's star, but not really like for the foreseeable future. All right. So we're kind of, not really going the same direction per se, kind of headed off in different directions a little bit. So Barnard's star is at least similar enough to the sun that it's still mostly in the plane of the galaxy. There's plenty of other stars that are not so much in the plane of the galaxy. That's kind of a nice one. Woo! That one's kind of all over the place. So in the plane of the galaxy, but not really going quite in the direction that we're headed. So it turns out the sun isn't really part of a moving group. The sun's not part even of an open cluster that we know of. So there's all these other groups around us, but we're not part of one. We're kind of alone, but in a sea of other stars. Alone, but not alone, which is like very New York, I think. That's New York for me. It's like there's people everywhere, but you can still be alone if you want to. So let's go ahead and take a look at some groups of stars that are not alone and see what that looks like. So we'll turn off these other orbits, and I might need to turn on some references, just some constellation lines for reference to help me find my way around, because it's a great big galaxy out there. It's just one galaxy, but there's a lot of stars. So if I turn on constellations, there's a couple of them. All right. So we'll move out a little bit further. So you might recognize some of these. So these aren't all the constellations. Those are just the constellations that lie kind of along the plane of the solar system. Some of the zodiacal constellations are in here. And if we move out, we should get to some groups of stars. There's one. All right, so here we have one of the groups of stars that we saw earlier in Stellarium. So this is the Hyades. So Hyades is this kind of loose group of stars. It's one of the closer open clusters to us. Um, about 600 million years old. So these are relatively young stars and not too many. So most of the moving groups are going to have, from 10 to 100 stars. Um, so this is more of like a cluster, more tightly bound and some of these moving groups. So this is kind of how stars are born, right? So they're kind of born from a huge cloud of gas, a giant molecular cloud, and pockets of that cloud will condense and form all these stars. So they all kind of like are in a little collection from where the cloud used to be. And then sometimes they hang out together for a while, and sometimes they just drift apart. So the Hyades, being, less than 1 billion years old, in comparison, our sun is about 4.5, 5 billion years old. So these are still relatively young stars, but it's still all just kind of hanging out together in space, not really drifted apart just yet. If we move out, there's an even younger cluster that's just a little bit further away from us. That's also, here we go, the Pleiades. Which I mentioned, really, really nice to see in in binoculars again. So the Pleiades, those are a bit younger. So here we're 1.3, yeah, about 100 parsecs out. So maybe 500-ish light years away for the Pleiades. But another group of stars, much younger. So the Hyades, again, those are like around 600 million years, so over 500 million. The Pleiades are closer to 100 million years old. So much, much younger, a little bit smaller. So we have a couple really bright members of the group, and then some kind of fainter ones. So you can kind of just float around in here and enjoy the view of the Pleiades. So this is much more dense than most moving groups that we would consider because they all kind of form together, but they're all pretty close in. So generally with moving groups, the stars aren't nearly that close together. So just kind of drift away from those, I guess. So the sun obviously formed with other stars way back when, 4.5 to 5 million years ago, but it has since kind of disseminated. That group no longer is like all connected. So they've all kind of drifted apart, as the Pleiades and the Hyades will do eventually. So some clusters drift apart more quickly than others. One group that has drifted apart a bit more, still working on it. We come around here is it's kind of giant cluster / moving group that's hiding in plain sight for a lot of people. The set of blue lines. So if we come around here, let's see, come back in here. This is a group of stars. Some of them are part of the moving group, some of them are not. So you may or may not recognize this. If I got this lined up exactly with the sun, then it would still have kind of the same shape. Yeah, there we go. Ish. It's similar. So that's basically the Big Dipper. So Big Dipper is an asterism. It's part of the constellation Ursa Major, but 5 of the 7 stars in the Big Dipper are part of a moving group, and you can kind of tell which ones are outliers, right? So Alkaid, which is the one kind of off to the left, and I know Alkaid is the one off to the right, and Duba, the one off to the left, part of the cup, and then Alkaid, part of the handle. Those are our outliers. Those are both a little bit further away than the other 5 stars. So those 5, and you can see a few other stars right around in here, are all part of the same moving group. So what really makes a moving group? They have to have certain things in common. So they have kind of a common origin. So they probably all form together. They have about the same age. They have about the same chemical composition. They have the same motion through the galaxy also. So if we looked at kind of the direction that all of these stars were moving, it turns out that these 5 stars, along with a few others, you can see kind of booking it with them that are closer in, those are all moving in the same direction at the same speed, more or less, around the galaxy, whereas these others that are still, they're kind of along the same line of sight, but they're moving in very different directions. So even if we had 2 stars that were right next to each other or relatively close, like the Sun and Barnard's star, just because they're close doesn't mean that they're headed in the same direction as we saw. So all of these stars are actually part of the same moving group. So the next time you look at the Big Dipper, you can say, oh, look, it's a big group of stars moving together through space. That's pretty neat. And it actually includes stars from a few other constellations. So even though they're a bit further away, they have all those other things in common. So a common age, common chemical compositions, kind of a common direction that they're moving. So there's even some stars from Orion, Aquarius, and Taurus, and Draco that are part of those, which is interesting. Like Draco is right there on the same side of the sky, but Orion is like way over on a different side of the sky from us. So it's kind of a big spread out group of stars that are kind of all, again, moving more or less together. So there are several of these all over the sky, actually. And if we pull out just a little bit of background in there, there's a lovely image you can find in Wikipedia that actually shows some of the associations, some of these moving groups. So it has like the Pleiades cluster, and the Hyades are also on here. But then it has like some of these other groups that are basically named after, the constellation that's kind of in the center of the moving group. So you see Scorpius association, Centaurus, Argus, Octans. These are kind of like in the southern part of the sky. Tucana, there's our Ursa Major cluster and the Hyades. So several of these all over the sky, but it's hard to tell just by looking up in the sky because, we have a relatively limited view, just looking over a relatively short period of time. So those are just a couple groups of stars moving around our galaxy, kind of together, kind of not. Some of them more spread out than others, but just some loose associations. So some clusters, those groups of stars that were actually born together and are moving around together. We'll talk more about a different type of cluster next week. I just kind of point out a quick difference if we look at where some of these other clusters are. So I said the moving groups are kind of spread throughout. The open clusters, those are more concentrated, right? So we can like kind of blob those. So each of those green dots is an open cluster, not necessarily a moving group, but a group of relatively young stars that all form from the same cloud of gas, and over time could evolve into a moving group when they become less associated, kind of drift apart and leave the nest, so to speak. So most of those are in the plane of the galaxy. If we move out a bit, you can see those future, those are moving groups to be, that are all more or less in the plane of the galaxy. That's just one type of star cluster. And then a type of star cluster that I want to see some details in more next week. Our other type of star cluster we have, those are the globular clusters. And those are not just so much limited to the plane of the galaxy, but they're above and below the plane as well. So kind of in a halo around the galaxy, but they're whirling and swirling around it. So as they go through the plane, interesting things might happen. And that's what I want to get into next week. So this week, moving groups, a little bit of review of clusters, and next week we'll talk more about globular clusters and some effects that they have on us, or at least on the stars, not so much us. So in the meantime, we'll just take us back. So I talked about how alone we are, so I might as well bring us back to Earth, and end up here, earthy like. I think I'm actually centered on the sun, so let's not get too close, get burned up. So so that's our very brief tour for this evening. Again, I'm Irene Pease, you're a friendly neighborhood astronomer. If you have any requests for topics, feel free to leave them in the chat. I'm always interested in what people are wanting to see and hear more about. So please feel free to contribute any ideas. If you like the visuals, want to download those, fly around on your own, you can find Stellarium at stellarium.org. You can find Open Space, what you see in the background now, at openspaceproject.com. Thanks again for joining me for this short little stroll around our celestial neighborhood. I hope you have a good week. Clear skies, be safe out there, and wear a mask.